Advanced Financial Modeling with Python. Learning objective number 3, you're going to import and manipulate time series data directly from the web. So what you do is we're use a package called YFinance for Yahoo Finance. And it's a source, or it's a tool or package to download market data. By the way, YFinance is not actually affiliated with Yahoo Finance, but I guess that's where they get their data, and they call it YFinance. If you want to know more about YFinance, you can go to this link here. So we're going to create a new notebook, and we're going to call it yahoofinance.ipynb. That's the integrated Python notebook. And then we're going to load up these packages. So let's first go to here. I'm going to do a file, new folder, or new notebook. You are going to rename it right now to Yahoo Finance, all lowercase, Yahoo Finance. I'm not going to do that, so Yahoo Finance. And then we're going to go and grab this code to load or import the particular packages. So we're going to click on this, and we're going to copy these lines of code, 5 lines of code. And we're going to execute them. You can see it's pip install Yahoo Finance, YFinance. Pip is as a command for Python for installing packages. So it's going to pip install Yahoo Financials, pip install YFinance. It's also going to import pandas as PD, import YFinance as YF, and then from Yahoo Financials, import Yahoo Financials. All right, so this is just getting all the packages ready to go. It's like loading up your tools or add-ins in Excel. We'll run that. Okay, it doesn't look like there's any errors in there. And we're all set. I'll add an extra line of code. All right, so here's what we're going to do. We are going to get data directly from Yahoo Finance to calculate the beta of Capital One financials over the last 5 years. I did a little research by Googling and ChatGPTing, and I asked it to give me some Python code in Colab to calculate data directly from the web. And from that code, I've determined that this is this program seems to work. So what you need to do is using this Yahoo Finance, you're going to specify something called a ticker. That's going to be the stocks ticker. And it's going to be yahoofinance.ticker, and then you put the ticker name COF. So you're creating a variable in Python called ticker, and then going to Yahoo Finance and getting Capital One Financial. Then using the Yahoo Finance ticker history, you can specify that I want a new data frame called COF_DF. I just made up that name, Capital One Financial data frame. And I want ticker history period equals 5 years. That means trailing 5 years. And then I want to, from Capital One DF, it's actually going to be a matrix of kind of opening, closing prices, and so on. I want to actually just pick up the closing price from that Capital One DF that was created from Yahoo Finance. And I want to give it a title, Capital One stock price. And then I want to take a look and see what COFDF looks like. So we're going to copy this code. Come back. Paste. Run that. Notice the last line of code is just showing me what COFDF looks like. I put in a plot in there, cf.plot. This is the full data frame, and then hopefully I've trimmed it enough. Let's take a look at what COFDF equals. Again, one more time. Well, looks like it is a full data frame where you have, looks like dates, open price, high price, low price, closing price, volume, dividends, stock splits, and looks like that's it. So we'll have to deal with that. Let's go ahead and copy all this code up here that we just ran. And let's do the same thing for the S&P 500. It's a nice little graph of Capital One stock price from 2020 to 2024, or 19 to 24. I'm going to add some code here. I'm going to paste, and I want to do the ticker for the S&P 500 is GSPC, which means I'm going to change this to GSPC and this to GSPC and GSPC. So I'm grabbing the GSPC ticker from Yahoo Finance. And we can just change this to be S&P 500. Let's run that, see how it looks. Oh, not getting any data. Let's take a look. Oh, there's an error. In Yahoo Finance, it is actually for indexes. You're going to put in the hat sign, GSPC, and I'll just leave the hat sign one time. So that's the true sim. Let's see if that runs. Okay, that's looking better. Again, this the caret GSPC is the actual symbol in Yahoo Finance. There's the S&P 500, and we're looking pretty good. Now, what we want to do is, at this point, now we just want that closing price column out of the Capital One Financial data frame and out of the S&P 500 data frame. And this is similar to what we did in the last sections. So we're going to say GSPC equals GSPC data frame closing column. That's basically what this is saying. And COF equals the COF closing column from COF data frame. We'll then return or convert those to returns by using the percent change. So let's grab this code. And I have a print for COF returns and print for GSPC, but you could just type COF returns and GSPC returns. I'm going to copy. Run that. Looks like it's just picking up dates in a big column here, and then I have returns. Looks like there's an extra return. There's 1,258 observations, but that extra, not a number, that's because when we convert the prices to returns, if you have n prices, you have n minus 1 returns. So guess what we're going to do? We're going to trim it. We're going to trim it. By selecting one less row. I have that code for you over here. We're going to do GSP returns equals GSP returns 1 to 1258. That's going to take one data off and the C data one item out. And then we'll just take a look at the COF returns. So I'm going to copy this, paste. So again, it's trimming GCSP returns and COF returns and just printing over it. Okay, now I don't have that NON, and now I have 1,257 observations. All right, so pretty good. I've got returns in columns of the S&P 500 and Capital One for the last 5 years. Now I can go right to my program I ran the regression last time. I'm going to import NumPy as NP. And then from sklearn, I want to import linear regression. Set X as the S&P, set Y as Capital One returns, and then the model will run the beta, the regression coefficient, or model coefficient, and then print it out for us. Let's go ahead and copy this code. And we're going to run that. I'll do a Shift Enter. And we got a beta for the last 5 years, trailing 5 years of 1.43. It's about right when I check some other websites. So I think we're in pretty good shape. We'll do one other thing before we move on. And that is, well, since we already have these arrays of returns, what else could I do with it since I have the, all these tools loaded up? Well, maybe I'll just calculate the standard deviation. Let's say that capital One STD, new variable name, is the capital One returns.std, which is a tool within one of the packages. And then what it's going to give me is a daily standard deviation. Then I'm going to multiply times the square root of 252. And then I'll do the same with the GSPC. GSPC STD equals the GSPC returns.std. That'll give me the daily standard deviation. And then I'm going to multiply that times the square root of 252. And then I'll print off both of those numbers, or I can just type it and I can get a value there. So I'm going to copy that. Paste. And looks like I have capital One, last 5 years annualized vol is 43, S&P 500, 21%. So that was an easy one, wasn't it? So now you're really starting to see the value of Python. I think in the last section when we downloaded the data from Excel, I don't know if you saw the value that much because, well, I think we might have been able to do that faster in Excel. However, now that we have this code, now we could rewrite this program and just change the ticker to say Tesla. And I can get the last 5 years in Tesla. So what's your final assignment? In Yahoo Finance notebook, I want you to copy the appropriate program code to calculate the beta and volatility, both of Tesla stock, TSLA. So you can figure that out, what you need to run to figure out to get the prices of Tesla, then turn that into returns, then trim it, and then rerun the regression model with the new Y variable of Tesla's returns. All right, and then I want to see that inside the notebook, and then print the notebook as a PDF, and that's the assignment for this section. So I think hopefully you're starting to see the value of this new tool.